You're listening to the Common Descent Podcast.
Hello, Will.
Hello, David.
Hello, listeners, and welcome to a special bonus episode content-y thing of the Common Descent Podcast. This episode is about a special event that Will and I got to attend just recently.
Yeah, that we were whisked away to.
We were back at the end of August, just as Will and I were getting prepared to go off to Atlanta for DragonCon.
Mm-hmm.
We were contacted by Dr. Ashley Morhardt from St. Louis, who invited us to participate in SciFest, an event that was being put on as a collaboration between Washington University's Department of Medicine in St. Louis and the St. Louis Science Center. This was an event, it was called SciFest Rock Fossil Quake, and it was a bunch of cool activities and demos and professional scientists gathered at the museum to do some outreach for the public.
Yeah, it was a lot of fun, a cool event.
It was, and we were invited to be on hand to do some interviews, to get some pictures, to do some general social media-ing.
Some science reporting.
Kind of, yeah, a little bit of documenting the event. So here, we're gonna explain sort of what happened at the event, what sort of things went on. We got a bunch of interviews with the paleontologists who were there, so those will feature throughout this recording. And generally just a cool opportunity for us to shine a spotlight on a fun outreach event.
Mm-hmm.
And those are always worth highlighting because it's such a great opportunity to get to witness and participate in a place where you have professional scientists interacting with the public.
Yes, it's very important, we feel, to be able to have that moment where the people from the local community can actually directly talk to the people responsible for the research behind the science that many of them may be fans of or followers of.
Yeah, and it's a great way just to get people engaged.
Absolutely.
Here's some dinosaur bones being presented by the person who studies them.
Yeah,
is pretty cool.
Who names these kind of things?
Yes. And we know that it was in part an attempt to get a little bit more science outreach in the St. Louis area by the university and the center and the scientists there who are interested in that sort of thing. So it turned out, and it was great because we got to have some cool conversations with the scientists about science education and science communication.
Yeah, it was really cool to get their views on that. That was very interesting.
Yes. So like we said, over the course of this audio, we'll tell you about the event, but we also got a bunch of interviews, and you don't want to hear us talk the whole time. So I say we go right ahead and introduce the first couple interviews.
Yeah.
So the first two you're going to hear from, we're going to play them back to back. The first is Dr. Ashley Morhardt, who was a big part of organizing this event, who was our main contact getting us involved. She is a paleontologist at Washington University in St. Louis. And then the next person you'll hear from is Dr. Andy Farrkey from the Raymond M. Alf Museum of Paleontology in California.
Yeah.
Take a listen.
Have fun.
Hello, Ashley.
Hi, David.
Can you introduce yourself?
Sure. My name is Dr. Ashley Morhardt. I am an assistant professor at Washington University School of Medicine. I'm also a paleontologist, and I'm helping host the SciFest presentations here at the St. Louis Science Center.
Cool. Very nice. And you are not just one of the hosts, but one of the professional paleontologists on hand to talk about the science. So very briefly, what do you do? What's your research?
Sure. So I'm interested in the evolution of brains in the group of animals that includes dinosaurs, birds, crocodilians, alligators, so the Archosauria.
The best group.
Yeah, the ruling reptiles.
They're pretty good.
And so, as part of the studies of archosaur brains, I'm interested in looking at ancient archosaurs, and so dinosaurs that have gone extinct previously in the Mesozoic are part of that group. And so looking at their brains is a bit tough because they don't fossilize generally.
Yes.
But we can get a sense of size and shape of the brain from the cavity within the skull that has fossilized. So we do a lot of CT scanning of fossils, and we're interested in looking at the cavity within the skull using that X-ray technology and using 3D models to get a sense of size and shape of the cavity, which gives us a sense of size and shape of the brain.
And your table, so you gave a talk earlier, and you have a table, and your table has Triceratops brains on it.
That's right, yes.
And how is your table going?
Going well. Very exciting to see everybody come through. I think, we're interested in promoting paleontology in St. Louis in general. Right now, there's sort of a boom of paleontology in Missouri. We have a lot of representatives from the paleo community who have moved to and taken positions in Missouri, and so we've got a great community here. And as sort of part of that effort to build that community, we're also genuinely interested in building connections with the communities that we're in. And so seeing a great turnout here at the Science Center, seeing people excited about fossils, learning about concepts related to field digs and evolution, and just a lot of the topics that we cover in our own research that's cutting edge, they're getting to learn about today. And I think it really, because we're in the Midwest, we do have fossils here, but in terms of dinosaurs, there's a bit of a paucity. I grew up in the Midwest myself, and I know what it's like to sort of have a drought of dinosaurs around me. And so, paying it forward is my goal, and giving people a chance to talk to paleontologists and see fossils and talk about what is it like to be on a dinosaur dig. These are all things that I wanted St. Louis to have an opportunity to do. Yep.
And how will you, after the event, what will be your metrics to gauge if you've achieved those goals that you're looking for?
Sure. So that's a great question. So this is a collaborative event, obviously, between Washington University and the Science Center. The Science Center does a lot of work in general with their events to, keep track of the traffic, keep track of people's reactions to the event. Everything from right now they have a station where folks, as they work through the different displays and talks, have an opportunity to sort of vote on some of their favorite activities. And so getting feedback that way in a sort of on-site activity, but then also, of course, reactions from social media, engagement through digital outreach. These are all components to the event as well. And so, as far as gauging the success, for me personally, it's something that I care about a lot. And this is maybe poor science, but I know when it's gone well when the people who have come through are engaged and excited and talking and asking questions. And if we have a good crowd, which we do today. So all of that is part and parcel to knowing whether that gut reaction, whether we did a good job.
Yeah, you can get a feel just by observing the event and keeping an eye on how everyone's reacting to it, whether it's which kind of side of the board it may be on.
Right.
Cool.
And what has it been like? So you, as you said, you are hosting, and you've been doing a lot of work. You've been our main contact organizationally.
Yes.
What's it like to organize an event like this?
It's a lot of work, and it was something that I really, really wanted to do and devote the time to, in part because of what I said about wanting to grow paleontology, put paleontology on the map in St. Louis and grow the community here, but also just making sure that we are engaging in outreach. So through Washington University, there are a lot of opportunities to do outreach, but I have yet to come across any direct connection between WashU and the Science Center. And I feel like the Science Center is sort of an untapped opportunity for folks at WashU to come through and do outreach here. It's right in our own backyard. It's literally across the highway. And so building those relationships and also sort of creating a win-win situation where I am being able to bring in some of the people that I know are excellent paleontologists getting to see them, catch up, be friends, but also do research with them while they're here. And then also contribute to the outreach mission that I have personally and is obviously a big deal here at the Science Center. All of these things sort of make it something that's a high priority for me. Yep.
I think it's really cool that what you've managed to do here, you sort of the plural, you and everybody else participating, is you've gotten, so there is a public outreach event, a major public outreach event. You've got actual working scientists from behind the scenes engaging with the public, and you've got them getting together to collaborate on research projects, and you're going to be doing, I think, a demonstration. It'll serve as a demonstration tomorrow for the CT scanning. So it's a joint research and outreach and public engagement.
Yes.
If you're sort of rolling it all into one, which seems to me is even better than multitasking. It is fundamentally linking research and education together.
Which is, for me, I that's kind of how I see science anyway. I'm not the type of person who wants to do science in my office all alone. There are days when I need that space and opportunity to sort of think in a vacuum and clearly. But more often than not, I find myself gravitated to situations where I'm working in groups and we're working in a very inclusive and vibrant scenario or situation. And so I care a lot about education. I care a lot about making sure that our missions our research and teaching missions in paleontology carry over into the public sphere. And so it was an event that sort of grew out of my own lab's research. Well, SciFest in general is something that the Science Center does all the time. This is not they do it once a month, but SciFest, Rock, Fossil, Quake, and the contributions that WashU made this year to collaborate, those things grew out of my lab's, I guess, in some ways self-interest to do research with the folks that we brought in, but then also go beyond that and wanting to take advantage of the folks we had in town to make sure that we were contributing to outreach as well.
Well, it seems great from what we've seen so far.
Thank you.
And from the planning side of it, I have to say, being too that we're part of your juggling process, it felt very smooth on my end, being one of the people being wrangled.
Great, that's
well
great.
done.
Thank you.
And that was the last thing I wanted to say for this chat, is that you are also the direct reason that Will and I are here.
Yes.
As you reached out to us, which we greatly appreciate.
Thank you.
Because this is lots of fun.
Yeah, you're very welcome.
Really cool.
Happy to have you here. I think having you guys here makes all the difference in terms of connecting our event to the paleontology community and also the public. But I think a lot of folks in paleontology who are professional paleontologists or professionals that interact in paleontology are going to be listening to your podcast. And so we're doing sort of a multi-prong approach, and you guys are an essential component of that, to be able to record the talks. We've not really done that before, ever, here, for any event. And so having a record of that is exciting, and having an opportunity to do interviews and things like that will be broadcast is a huge deal. So thank you.
Absolutely.
Our pleasure.
I think, Will can correct me if I'm wrong, and depending on when this comes out, but based on the schedule we have in our head, I think you will be the first person besides Will and I to appear on 2 different Common Descent recordings, because you were in the diversity and paleontology bonus thing, and I don't think we've ever had a recurring voice on the podcast before.
Well,
so you get that honor.
Thank you. It's been a pleasure.
Yes, welcome back.
Well, and I would say too that the connection that we had to talk about that at SVP last year is ultimately what led me to reach out this time. So yeah. So that's great.
Well, I guess we'll keep doing it.
Yeah, it seems to be working.
It's working. Well, Ashley, thank you for talking with us. Thank you for inviting us, and thanks for making this whole thing happen.
Yeah, you're very welcome. Thank you so much for coming out and for recording.
Hi, Andy.
Hi,
How's it going?
it's going great.
Please introduce yourself.
Yeah. So I'm Andy Farrkey. I am the Augustine Family Curator and Director of Research Collections at the Raymond Museum of Paleontology at the Webb Schools. And with that, I'm also a dinosaur paleontologist.
Very cool.
And what sort of research do you do on dinosaurs?
Mm-hmm. So my main interest is with the ceratopsians, or horned dinosaurs, but just by virtue of what we find on our field program, I've gotten to work on a little bit of everything that lived during the late Cretaceous period.
Very
Excellent.
nice.
And are the ceratopsians your favorite things to work on in that period?
Yeah, ceratopsians are absolutely my favorite dinosaurs. They're just crazy skulls, really cool ornamentation happening with them. There's a lot of fossils, and there's a lot of questions that we're looking to answer with them.
I have always appreciated when it comes to ceratopsians the way they took, first off, just a part of the skull and went crazy with it, but how many different versions of the frill that they've made. I've always liked the fact that they've been so creative in that way.
Yeah, that's the way I often describe these things is they're kind of like the Mr. Potato Heads of dinosaurs. You take like your basic skull, just take that standard basic skull and you just like put things on it, different, switch it out and you got a new species there.
It's like for anyone who played the 64 Mario world where you could pull his face.
Oh, Super Mario 64.
Yeah.
You could squish and move his face
You
around.
can pull his face. That's what it makes me think of. It's just
that's what it is.
Grab the corner of your head and then pull, and you have a horn, and just stretch it.
So what kind of questions are you looking to answer these days?
Mm-hmm. So part of it is, what were the species relationships of horned dinosaurs? So what were their evolutionary patterns? What was most closely related to what? How did they evolve? What was the rate of their evolution? Maybe what things correlated with particular evolutionary events. I'm also really interested in the way that they function. So their anatomy and their what's called functional morphology. So basically, when you have a Triceratops, how does it move? How does it use its body? How does it use its horns? All those kinds of things. And I get at that through, some of it through comparative anatomy. So looking at the bones and comparing them with other bones from other animals or maybe living animals today. Another thing I like to do is look at, it's called pathology. So injuries or what's probably injuries on the skull, looking for maybe patterns of horn use or things like that.
Didn't you do a study not too long ago where you got effectively toy dinosaurs and bashed their heads together to see where you might expect to see injuries?
Yeah, so it's actually a little longer ago now than I like to admit. It was published back in 2004.
Okay.
But so I basically got plastic dinosaurs and I made them fight each other. It was all for science, and
of course.
That the interpretations from that study showed that while there's parts of the skull that we would expect maybe to have injuries based on the way that what I observed when I was making my plastic dinosaurs fight each other, and then I took that in the next study. I took it a step further and actually looked at fossils and to see do those patterns on the fossils compare with what I predicted from the models. And in many ways, the answer was yes. Yep. So we did see patterns of markings on the skulls that were consistent with where you would expect to see injuries from fighting.
See, I love that because so often scientific, but even paleontological research is shown, the way it was at the beginning of Jurassic Park, where it's people using computer, virtual reality gloves and giant graphs and things where it's unintelligible to the common eye, but you can come to really cool conclusions by using very straightforward observations, which is really, I like that.
Yeah, I mean, there's always a place for computer modeling and those sorts of tools, but oftentimes, you get just as much, if not more, for a lot cheaper, just by doing kind of physical representations of it.
Yeah.
Very cool.
Now, here today at SciFest, you have traveled quite a distance to get here, all the way from California.
That's right.
So what is it like? Do you do a lot of traveling for science outreach and events like this?
Yeah, it's not often I travel outside of my state for outreach. I do it from time to time. I do a lot of things kind of regionally in Southern California, both individually and as part of my museums team, doing different science festivals or community events. And it's a lot of fun to do these kinds of things. You get a lot of interactions with different sorts of people, maybe people that haven't necessarily met a paleontologist before. So it's exciting for them, and it's exciting for me, really, because people come here often with a type of enthusiasm, that it kind of brings me back to those days. It's like, oh yeah, this is what it was like to be this excited about a dinosaur. And it's kind of cool. It's energizing for me, and it's also just a lot of fun to kind of have that back and forth with visitors and guests here at the Science Center, talking about scientific questions and getting them to look at the world in a different way, and at the same time I'm looking at the world in a different way too, seeing it through their eyes.
Absolutely.
Yeah, I like that. I like that view on it, and that it really is like going back to when you were first discovering it.
Yeah, and that's the challenge. I mean, because I've been a PhD scientist for so many years now, and a lot of what I do is talking with my colleagues in the field, or people that also have PhDs or advanced academic degrees, or at the very least, really interested and dedicated amateurs. And of course, we all speak the same language in general, and it's hard sometimes to shift gears and be like, okay, I can't. It's not that I can't say that word, because you don't want to dumb it down, but you have to build up, to a certain concept or a certain phrase. Like I just can't say rostral bone immediately and expect, that they're going to know that that's the bone at the front of a ceratopsian skull, or even what a ceratopsian is. But you get to kind of scaffold, you kind of build up towards that, and then you get to the big payoff of here's a really cool technical term that describes it, and this is what that means, and then they get it, and that's the fun part of it.
Yeah, being able to dial in. What words need definition and what don't. Yeah. That was definitely one of the things that took me the longest when I was starting working with the public on figuring out, I don't know what you know. Yeah. Yep. And it's interesting to find where that line is.
Yeah, and then you get the person where they know way more than you thought they did, and then you got to totally shift gears, and that's fun too. I think the thing that's really fun about these events is that a lot of it's just so spontaneous. Every interaction is a little bit different. Every person's coming to you from a different place. So you really just kind of have to be thinking on the fly the whole time. So you're not necessarily doing a lot physically, but at the end of the day, you're just exhausted. If you've been doing it right. Yeah.
It's very improv in that nature.
It is. Yeah, that's exactly it.
And how do you think SciFest is going?
It's been really fun. I've enjoyed all the interactions, a lot of different people from the St. Louis community. I think in terms of the size of it, it's been perfect. It's been busy, but it's not been insanely, just a crush of people. So we've just had really steady stream of great interactions, with people of all different ages and backgrounds. So it's been fun.
Excellent. And then coming here, anytime you have scientists traveling, you always want to make it a research trip. And coming to visit Dr. Morhardt, Ashley, who is also a ceratopsian person, do you have plans, or have you already been putting your heads together over some ceratopsian research? Yeah,
it's been really enjoyable to chat about some potential projects with her, some descriptive stuff related to brain cases and brains and all that. And just kind of catch up in general, hear what she's working on, and talk about what I'm working on. And then I think we have the advantage also, we're being here at the Science Center, which has some fossils in-house. It's been really fun to talk with her and with some of the volunteers and the staff at the Science Center about what they have, because I just love seeing these kinds of fossils.
Yeah.
So it's been very energizing.
Nice. We always talk about how, you'll hear this very commonly. We've said it, other paleontologists will say it. You go to conferences and you come away just full of new ideas and inspired, either about research or about education and things like that. Do you find yourself inspired by the conversations and interactions you have with the public at events like this? Does it send you back home thinking in a different way than you were? It
does. I mean, part of what it gets me thinking is about, I learned a new way, or I figured out a new way to present something, or a new, a trick that works, and getting people to connect with the field. Sometimes it's just excitement, you meet that one student or that one family that's just so enthusiastic about it. And I really enjoy seeing that enthusiasm, from people that aren't necessarily paleontologists, because it reminds me what I get to do. I'm privileged to do something that's really pretty cool that people are interested in. And also I get excited, who knows, maybe today we met, one of the next great paleontologists, who's going to, in 20 years, is just going to take the field by storm. And I think that's a really neat thing also, is thinking about, what could be, as a result of this.
Yeah, this might be the memory that sparks them, or an event like this might be able to be that inlet for them.
Mm-hmm.
Yeah, they'll say, so they'll be on a talk one day, you guys are, and they'll say, what inspired you to get involved? And they'll say, I met Dr. Andy Farrkey 20 years ago.
Yeah.
Now, before the day is over, you'll be giving another talk.
Mm-hmm.
And just very briefly, what is your talk going to be about?
Yeah. So the talk is going to be about how my field identifications of fossils suck. Of course, they'll be talking about some of the science on these related fossils, but the theme is really going to be about, when you find a fossil out, in the Badlands or wherever you find it, you don't always know what it is initially. You have your first guess, and then as you collect it and then you bring it back to the lab and it gets prepared, in some cases it turns out to be something way different than you ever expected, and in some cases you're absolutely spectacularly wrong in your first impressions, and that's when it gets really fun. So I'm going to talk about a couple examples of that from my career.
Very nice. Excellent. Well, we're looking forward to that.
Absolutely.
Andy, thanks so much for talking to us.
All right, thank you.
So a big portion of this event, a big focus, was paleontology.
Yes.
They filled the place with fossils and paleontologists. That's, the main reason we were invited and got interested, because that's sort of our thing. So let's talk a little bit about some of the paleo stuff that was on hand.
Definitely.
What did you like, Will?
So first and foremost, the Science Center has some really cool paleo stuff on its own. They have a big fun animatronic T-Rex next to at the moment, dying animatronics Triceratops due to the T-Rex next to it. But they also had some digging areas for the kids and some cool fossil displays. And they have a prep lab at the Science Center that was enrolled in the event, which was very cool. They had people working on fossils while the event was going on, as well as the paleontologists with fossil tables, upstairs from that. So I liked that both of those were able to be a part of the event, and they could see fossil casts and some actual bones, but then also people putting the fossils together, which was very cool.
Yeah, it was really neat to get so many different people involved in the event like that. And in their fossils, too. I think I commented at one point that there were 2 Triceratopses that had just been exploded across the event.
Yes, absolutely. Different parts of them at different tables.
Yeah. So people got to engage with the museum stuff, but then the tables that, like you mentioned, each of the invited paleontologists, and you'll hear from all of them over the course of this episode, each one had a table.
Yes. And they had a wide variety of things represented on all those tables, which is fun.
They did, yeah. Dr. Freedman Fowler had a bunch of hadrosaur bones. Ashley, Dr. Morhardt herself had, which might have been my favorite thing. No offense to anyone else's table.
Yeah.
She had a printed out endocast model of a Triceratops brain case.
Yeah.
And what a great little colorful plastic thing for kids to be able to interact with. And adults. As soon as she showed it, I was like, can I hold it? Because it looks super cool.
May I hold the brain?
Yes.
I really liked that the brain case endocast, because at a distance, no way you're going to guess what it is, but it's colorful and it's a very unique shape. So it draws your attention. As soon as you get to that table, oh wait, what's that?
Yeah. This
thing looks like a very weird alien water bear. And it's neat. I like that because it's so alien looking, and then when you're like, oh, this is a shape of the inside of a Triceratops skull. Oh, well, that's intriguing.
Yeah, and I think that's a really good approach to draw people in. She also had a Triceratops toy.
Yes, she did.
Which is, a fun little thing, but it's great because that's engaging for people.
And it connects it, because she had part of a Triceratops skull, but if you just glance at it, there's no way you're going to know that it's a Triceratops skull unless you're one of the researchers there at the event or a few others.
Yeah, it was the brain case.
Yes.
So it wasn't like the horns and the frill and stuff. It was the part that she was studying. She studies interior of ceratopsian skulls.
So like looking at this piece, you didn't even see many outer edges of the skull. So you wouldn't have recognized the feet. You had the back of the skull where it attaches to the spine, and that was the only recognizable thing for me.
But then to be able to say, this model is the shape of the inside of this real skull right here.
Which is the inside of this animal.
Yeah, that's awesome.
It was cool.
That was really neat.
We also had a lot of tables with cool just varieties, just cool assortments of different fossils from different groups, not just dinosaurs, but other cool organisms.
Yeah, there were a bunch of dinosaur, Triceratops especially, frills and horns. Will was very happy.
Yes, I
because there were a lot of Crocs.
There was a lot of cool Crocs. We came across one little Croc skull, one little alligatoroid, so cousins of alligators. One little alligatoroid skull, not very big, but it had teeth that were flat like marbles. It was so cool.
Yeah, this was at the Burpee Museum table.
Yes, it was downstairs.
With Josh and Dan.
And so it was.
I forget the name of that croc.
I don't remember the name of it right off, but it was alligatoroid. Skull was probably 8 inches long.
The size of your hand.
Yeah. It was just a little one, but the back teeth were flat, very much like a caiman lizard, as David pointed out, which is a really good example. So if you go look up a picture of a caiman lizard, it looked like those teeth in the back, which is so cool and weird. It had smashy teeth. I loved it.
We'll put up pictures that we took of the tables and of some of the specimens and stuff in a blog post as well, so be sure to check those out.
I do have pictures of that one, so we can share those.
Yes.
I took a few.
Most of the fossils were Mesozoic.
Mm-hmm.
So there's a lot of dinosaurs, there's a lot of gators. There were no snakes, unfortunately, but not every event can be perfect.
Well, they were allying it with the pole.
Anyway. But there was a table from the University of Missouri with a bunch of hominin skulls.
Yes.
Which was really fun. We didn't actually get to spend as much time at that table as I would have liked, partly because it was full of visitors.
It was popular. Yeah.
Yeah. And we didn't want to interrupt, okay, no, this is what this is for. I've seen hominin skulls before.
Out of the way, kids. I want to look at this cool stuff.
We're with the podcast.
Do you know who we are?
Don't you know? So that was really cool to see. It's always nice to get, even if they're, silly primates.
And thumbs.
It's nice to get people exposed to a diversity of different types of fossils, which is really fun.
I think one of my favorite things that table had was they had cardboard cutout type stands of different ancient hominids.
Yeah,
so
they did.
You could stand next to Lucy and Australopithecus and Homo erectus and measure yourself up eye to eye. And that was actually really neat. And it was the nice skeletons laid out, so it wasn't like a reconstruction, it was the actual fossils, which is that's cool.
I think my favorite thing that I saw at any of the paleontology tables was there was one kid who must have been maybe 10 years old who was at Andy's table, Dr. Farkey's table. He must have been there for like 10 minutes. Just one-on-one talking to Andy about fossils and like about paleontology research, it sounded like, and what you can do with fossils. And that was really cool. How often do you get the chance to have a child who's interested in the science talk one-on-one with a paleontologist?
Yeah, with a researcher. Someone who's actually... A lot of the paleontologists at this event were obligate field paleontologists much of the time, and all of them had been in the field. So you were actually getting to talk with the classic image of the person out in the rocks digging it up.
Yeah, the people who find them and study them and name them.
That's cool, especially for a kid that may be an aspiring paleontologist themselves or just very interested in the subject.
Absolutely.
There's actually a lot of very astute children at the event. Lots of really good questions from kids.
Yeah, so there were a handful of talks as well. In the evening, there was a series of talks and then a panel discussion with an audience of all ages that got to ask questions. And rarely have I seen an audience where you can get equally interesting questions from senior adults and elementary school students.
I was vastly impressed by the quality and creativeness of some of the questions the kids asked. Questions I would not have thought to ask. I knew the answers to some of it, but there was a couple where it's like, I also now want to know the answer to this, please.
Yeah, so it really did do that job. And the same thing with throughout the event during the day, there were what they called fireside chats. And 3 of them were the paleontologist in pairs, the same pairs that we are playing the interviews in.
Yep.
Ashley and Andy had the first one. And it was just the moderator, Ruth, who also works at the science center there, who was awesome.
Who was super
by the
cool.
way. Ruth was great. Would ask questions, and then the audience would ask questions. And it was just this wonderful opportunity, again, for visitors, kids and adults alike, to, share their curiosities with working paleontologists. Honestly, it was a lot of the same reasons why our DragonCon panel was so much fun.
Yes, it was. It was very much the same kind of guest and audience participation and engagement that made it so cool and interesting.
Yes, it was. So there was a lot of paleontology to be had there, and there was more than just paleontology. But before we continue talking, let's go ahead and play another couple of our interviews. The next pair are the 2 paleontologists that did the second fireside chat together. You're about to hear from Dr. Denver Fowler of the Badlands Dinosaur Museum and Dr. Casey Holliday of the University of Missouri. Hi, Denver.
Hi.
How you doing?
Pretty good. Been a long day.
Yes, it has. A good day, though, hopefully. Please introduce yourself before we start with other questions.
Yeah, so I'm Dr. Denver Fowler, and I'm the curator at Badlands Dinosaur Museum in Dickinson, North Dakota. So we've had a bit of a name change. We used to be called Dakota Dinosaur Museum, but we've changed in the last year to reflect a change in the ownership of the museum.
Okay. And you're one of the invited paleontologists here for SciFest today. So what sort of paleontology do you do?
I do a lot of field work. I did my PhD at Museum of the Rockies in the Jack Horner, so we did a lot of field work there, collecting dinosaurs in the Hell Creek Formation and the Judith River Formation, 2 of the big places I work. So I do a lot of field work, and I tend to do research on anything I find, or if I have an idea about something different, I just explore that idea. Just go where it takes me.
Very cool. So you're not some paleontologists are very loyal to a taxon, to a group.
Yeah, I work quite a bit on ceratopsids, so I've done a lot of work with John Scanella on Triceratops. And before I went to Museum of the Rockies, I worked quite a bit in New Mexico with Bob Sullivan, working out of Pennsylvania at the time, on Pentaceratops and some of the Chasmosaurian ceratopsids down there. So I kind of approach everything, first of all, through a sort of ceratopsid filter, especially things like horn size or evolution. I think about ceratopsids first. They're my example animal, but I work on lots of things.
That's your first question when we're presented with a new. All right, how big is it? Are its horns? No horns. Okay, very small.
Yeah, that kind of thing.
So it must be fun to get to visit here, where you have people like Ashley, who is another ceratopsian person, and there's what it feels like 2 exploded ceratopsian skulls scattered across the tables of SciFest today.
Yeah, there's some real nice stuff that they've collected here. I was very excited to see the one that was in front of Andy. It has a beautiful, big Triceratops, which was pretty cool to see.
Yeah.
So yeah, some real nice material.
And you have some cool stuff in front of you at your table. So what have you been talking about at your table today?
I've been talking about one of the projects we did a few years ago, looking at tooth marks made on Triceratops bones, specifically Triceratops skulls, which sounds a little bit weird, actually, when you think about tooth marks made by Tyrannosaurus, mostly Tyrannosaurus. You don't think that they would bite into the skull all that much. So the fact that we have quite a few skulls now with tooth marks on tells us an interesting story.
And what is that interesting story?
So the story is, there's a few things we can look for. One is, where are the tooth marks made? So we find a consistent areas of the skull where they make the tooth marks. So around the edge of the frill. it's quite common to find tooth marks. We find tooth marks very commonly on the ball on the back of the skull, the occipital condyle. Big tooth marks. We also find tooth marks in the nose area of Triceratops, but those tend to be quite delicate tooth marks. So this starts to paint a picture. I should say we've got 25 specimens now, 25 skulls or partial skulls that show these tooth marks on them. So it's not just a one-off where one tyrannosaur ate a Triceratops in a particular way. It starts to show a consistent pattern of behavior about how tyrannosaurs ate Triceratops.
Very interesting. Those are not 3 spots I would have bet money on, especially not the back of the skull, at the joint there.
Yeah,
that's
you'd think they'd go for like muscly, fleshy places.
Yeah, legs and bellies and easy to chew.
Yeah, what we think is going on is we think this represents late stage carcass processing. So when most of the good or easy meat's gone on the rest of the body, maybe the head's left there. And so different marks correspond to different kinds of behavior. So if you look at a skull, there's not much meat on a skull, especially a Triceratops, except it does have a big fleshy nose area. And so I think the delicate marks on the nose area, those are made by the premaxillary teeth of the T-Rex. So it has these, we call it an arcade of teeth at the front of the snout, which can delicately scrape meat from certain areas. So it's delicately scraping meat from the nose. The marks on the back of the skull are something rather different. So we think it's gripping the frill in the mouth of the T-Rex, and then it's pulling the head either off the rest of the skeleton, or it's just pulling it over so it can get at the big neck muscles.
Yeah.
So Triceratops has a huge head. It also has a great big heavy head, and it needs a big, thick neck, muscular neck, to hold that head up. So the marks that we see on the occipital condyle is when T-Rexes rip the head off the Triceratops, and then it clamps down its teeth around the occipital condyle and scrapes that meat, maybe the last meat, from the neck area. So, and we found that on something like 6 or 7 occipital condyles. So it's actually quite consistent again. So it's kind of cool, like, think of T-Rex popping the heads off all these Triceratops and then eating the meat off the neck area. But we think that's what's going on.
It was putting nothing to waste is what these tooth marks are showing, is them going and getting the bits of meat that aren't the easy ones to reach.
Right, and I think that's one of the sort of more in-depth things you can draw from this, is maybe T-Rex is unusual amongst theropod dinosaurs, that it can process a carcass more efficiently. Yeah. It can take more meat off a carcass than perhaps something with more slender teeth can do. There's a lot of different aspects of that. So the really thick teeth of a tyrannosaur, some people think it's for biting through bone. I'm not really an adherent to that idea myself, but I think that extra thickness is for good lateral strength, so that it can break apart carcasses and more efficiently pick off the meat that's there. I don't actually think that T-Rex is eating bone on purpose.
Yeah, it's like us pulling a turkey leg off of the body to eat it, instead of trying to eat the carcass as a single item.
Right, and one of my favorite marks that we see, it kind of shows a behavior a bit like that, where we have a mark on the back of a frill where the T-Rex bit in and then it shook back and forth. We have a zigzag in the mark. And this is a double mark, so it's made by at least 2 teeth. It zigzags where it shook backwards, and then it twists off sideways. The marks then go off completely at 90 degrees on a curve. So we can see it kind of shook like a dog sort of pulling at something, and then sideways movement.
It's wrenching it.
Wow. So a few of these things have those kinds of really cool multiple marks where you can see the movement of the T-Rex. You can see it doing something specific more than just a puncture or something.
See, all I can hear now is the dog with the chew toy sound effect from Jurassic Park.
Exactly. When he did the lawyer.
Yep, that's all I can hear.
It's insult to injury.
Now, sometimes outreach, communicating science to the public can be difficult, but this kind of thing sounds like it should be very easy to get people interested in that kind of narrative. How has your outreach gone today at your table and at your talk that you did?
Oh, it's been really good. I think it is very accessible. I think you see it a lot in the movies, and so I start out by saying, what evidence actually is there that T-Rex might have eaten Triceratops? And so what I really want to get across with it is what is the nature of evidence? Like, how can you find this stuff out rather than just showing it on a computer model? So we look at the tooth marks that way. And something I've been trying out today that we want to do when we eventually publish this research is I made a little model of a T-Rex jaw, if you like, using a ruler and some marker pens, where the marker pens are the teeth.
Oh, yeah.
And getting the kids to try and make a copy of the tooth marks, if you like, by drawing the pens across the paper. So we kind of want to develop that into like a classroom exercise where you can pretend your arm is the T-Rex and can you make the same movements as the T-Rex would have made. And that was pretty good. I think that I'll work on it a little bit more, but it's a pretty cool little idea.
Cool. That's awesome. I like that interactive. Anytime you can let the kids be the dinosaur.
Yes, absolutely.
Right. We talked to Andy about when bashing Triceratops toys together experimentally, scientifically. Anytime you can, basically, you get to play with the dinosaur pieces is a really cool way to get that idea across.
Yeah, it solidifies the memory.
So do you do a lot of outreach to the public back where you're from, or do you travel to do events like this often?
I've given talks to certainly the Burpee once, and probably somewhere else that I can remember. It's been a long day. We do quite a lot of school tours and things, do that, and I'm giving a public lecture in a week and a bit, giving a report on our field work. So every year I've only been in my job for like 2.5 years, so this will be our second annual field report. So we're going to report on what we did this summer, what we found, why it's interesting, maybe how long the public have to wait until they can see it in the museum. Because I feel it's really important to get that first step of the scientific process across to people. I think too often we present the results at the end of a study, and people haven't seen how you came up with the idea or what you did to collect the data and that kind of thing. It all kind of comes at the end. I like people to see every step so they understand the science process a little bit better.
That's great.
Yes,
I think
absolutely.
that's a great approach. And given your experience today and your experience elsewhere, what do you think of SciFest?
SciFest, it seems to have been really good. I kind of wish I could have gone around and seen some of these tables and seen what everyone had to say at some of them, but I saw a couple that were around me. But it seemed to be a lot of people, they're really getting stuck in, really interested. I mean, visitors, really, lots of visitors. It's been really good. I think, I hope it's been a good result for the museum here.
And we're not quite done as of this recording. You're giving a talk this evening as part of the talks, correct?
Yep.
And very briefly, what is your talk going to be about?
I'm going to be talking a little bit more about predatory behavior, but I'm going to be talking about a project we did looking at how raptor dinosaurs may have used their claws. So we looked at birds of prey and how they use their claws, and then we looked at different foot proportions in troodontids and dromaeosaurids and what that might mean about their differing ecology. But also we propose a brand new model for how dromaeosaurid dinosaurs would have used that really big sickle claw on the feet.
Cool. Very exciting. This is the kind of research that, if I remember correctly, got you the honor of being cited in an XKCD comic.
Oh, yes. Yeah, that got us a lot of reads that week on the article. But, that was, when we published that research, we tried to put it out as open access. This was a few years ago now when open access was perhaps not quite as big. And I thought, like, some things like you really want to try and encourage the public to read primary research.
Yeah.
And obviously having open access really helps with that. But also writing the paper in a way that's a little less dry can sometimes help too. So some scientists have commented that paper was a little lively perhaps in the language it used at times. But that was intentional to try and really to bring in people who perhaps might not normally read something with lots of Greek letters and things like that.
Yes, absolutely.
Well, we'll look forward to your talk later today, and thank you so much for taking the time to speak with us.
Yeah, thank you very much.
Hello, Casey.
Hi, how are you?
Good. How are you doing?
I'm okay.
Please introduce yourself.
Hey, I'm Casey Holliday. I'm an associate professor of anatomy at the University of Missouri School of Medicine.
Excellent. And what do you are one of the invited paleontologists here at SciFest. So what do you do? What's your research?
Well, I pretty much try to figure out how heads work. And that's with dinosaurs, but also crocodiles and birds and lizards and turtles and people. So I kind of pretty much wait for people to dig up really cool fossils, like the really best of the best, like the skulls. And I wait for them to dig them up, and then I swoop in and try to work on them and figure out how their skulls are built out of bones and cartilage and muscles and things like that. And we try to figure out how that whole works in terms of feeding or facial sensation or growth. And then we try to follow that up with how it all changes over time.
So you must be doing a lot of CT scanning and internal analysis and things like that.
Yeah, we CAT scan many things. I grew up CAT scanning things, and so it's kind of one of the standard tools that we employ. We use CAT scanning to not only kind of get a 3D picture of the whole specimen we're studying, but we can also do special scanning and really high-res stuff in which we can look at trabecular architecture inside of bone or try to identify the residues of soft tissues like cartilages. We look at how big nerve holes are and what that means for how sensitive the face might be. And we, of course, build muscles onto things to figure out how hard different animals might be able to bite or how they move their jaws.
Interesting.
Cool.
So it sounds like you were listing the variety of
Yes.
creatures you look at. It sounds like your specialization is more of the technique than in some paleontologists, or I do dinosaurs, or I do a certain type of animal.
Yeah.
So do you feel like you...
I would say we're very question-oriented as opposed to either taxon or technique.
Okay.
So in fact, trying to figure out how a head works includes understanding basic anatomy of living animals as well as knowing your osteology of old dead animals, because we need to be able to accurately imagine where all the muscles and arteries and nerves and membranes and fascia are in old dead things. Mm-hmm. And so we use straight up anatomy and dissection of recent animals to then figure out how old dead animals might have looked. We use histology to look at the nature of tissues. We use the CAT scan data to often build engineering models that we then kind of bend and break on a computer. So we kind of employ a whole lot of different things to really ask questions like, how does this head work? When did this particular cartilage evolve along the line to birds? How sensitive is the face of alligators? Mm-hmm. And when did that adaptation actually arise? So it takes a lot of different tools and techniques to get at these really interesting questions.
So basically, if you have a question about some fossil animal, you may have to answer that question for many other skulls.
Absolutely.
To get enough information for the one that is dead and no longer around.
Exactly. So, when you finally learn about how T-Rex might have been built, you've had to then learn 100 other animals already, and you learn that maybe T-Rex isn't all that interesting anymore. Because you've since learned that hummingbirds are really cool, or woodpeckers are really cool, or gharials are really cool, and so we end up spending 90% of our time on recent animals, so then we can say, perhaps, hopefully, the most accurate things about the old dead animals we possibly can using anatomy.
Yeah, within reference to all this new data. Mm-hmm. That's cool.
Nice. And this is perhaps reflected in the fact that sort of broad approach, reflected in the fact that your table, as you have a table here, has maybe the most diverse assortment of animals on it that we've seen of the fossil tables. So how is your table going?
Diverse, huh? Well, we only have archosaurs, and I think Burpee has trilobites and algae. So diversity-wise, I think they've got plants and animals covered.
Okay, so they got you beat. But how is your table going?
Our table's great. So we do quite a bit of outreach through the lab because I train up. Our students all need to learn how to talk to the public about the research we do, and so this is how we train up our students on how to talk to the public, which is throwing them into the public and have them talk. And so we kind of do these types of events quite a bit, both in our hometown as well as in other places. And it's a great way to show the public what we have going on inside of our lab back at Mizzou.
I think that's great that it sounds like you're incorporating that public outreach experience into the training of your students.
Yes.
Not just science, but also science.
Yeah, because, if you're going to get a PhD in a field, you become an expert, and experts need to be able to also translate and share that information with different types of people. And it requires different languages to do that. So you need the language of science that you might write with for papers or interact with at a conference, but then you have to then still tell the same story but with an almost different language.
Yeah.
With different groups of people like the public here or different other public events also.
Yeah, switching from jargon to a more accessible vocabulary.
Yes.
Yeah, absolutely. No, that's been something that's been very cool about this event, is that mentality seems to be shared by many of the people here, that scientists need to be able to reach out to the public to explain what they are doing.
Yeah, and part of our graduate program, a few other graduate programs do it, but we make teaching experience and outreach really a program part of our graduate studies, and that our students actually have to accumulate a certain amount of hours in outreach and education as part of getting their PhD, regardless of the core research they're doing.
Very cool.
That's great. And with that in mind, what do you think of SciFest today?
Well, I like SciFest. This is our second year here now, and the St. Louis Science Center actually comes to our outreach event called Dinosaurs and Cavemen Science Expo every March. So we're all in the same state, and we like to really try to raise awareness of all the good science that happens here in the state. And so I like coming because getting to present dinosaur fossils next to a giant roaring animatronic T-Rex, or with a different demographic of people. So people in Columbia kind of know our gang a little bit from the outreach that we do, but getting to come here to a much larger city obviously gets us a lot of really great exposure. And maybe people who see us here might then drive to Columbia in March and come to our event.
Yeah, or
something like that.
Give them that chance to be like, well, we're going to Columbia, and I remember, here, this is here for us to swing by.
Right, and our lab is funded by state-funded grant programs as well as federally funded grants, and it's super important for us to be able to show our taxpayer base what it is they're paying for. And there are ways that you can kind of drive around in the rural parts of Missouri and try to talk to those folks, but it's quite easy to come to St. Louis and talk to the folks from St. Louis area very easily, and you get to hit them all in one day who come here.
Very cool.
Now, as of this recording, you haven't yet given your talk that's going to come up at the end of the day today.
Yeah.
Very briefly, what is your talk going to be about?
Yeah, so the talk I'm going to give tonight is kind of a fairly brief story of how we've been trying to identify cartilages in fossils. Identifying cartilage is cool because it's quote-unquote soft tissue, and we don't think we're supposed to see things like that in the fossil record. And so it's kind of a story of how my old postdoc and I have done this project looking for cartilage in T-Rex skulls, because it tells us about when a particular type of cartilage evolved along the line of birds. So birds have this very particular weird cartilage that other reptiles can't grow. And we want to know when they first started being able to do that. And already it looks like they inherited the ability to grow particular cartilages in their head. They inherited this from their dinosaur ancestors. So we have to keep going farther back in time to figure out when this tissue might have evolved. And so it's a story of basically being able to cut up dinosaur fossils and then look at them and get permission to do so. And it's bearing really interesting fruits, meaning the things that we're learning and discovering are going to help guide years worth of research down the road, hopefully, by lots of other people as we try to figure out either A, how we can see, let's say, non-bony tissues in the fossil record, B, what that means for the development and growth of that animal, and C, what that means for how the skull might work. And so it's got a lot of potential, this project.
Nice. Well, we're looking forward to seeing that talk.
Yeah.
Well, Casey, thank you so much
for
talking with us.
Yes.
You're welcome. Anytime.
But of course, even though the focus of this event, especially for us, was paleontology, and they invited a lot of paleontologists from around the country, the event was rock, fossil, and Quake. And there was other stuff, including some really great geology and earthquake stuff.
They had some cool demonstrations to explain earthquakes. They had like some really neat visual and hands-on displays to show you exactly how do earthquakes function and what are some of the things that can happen. I think one of my favorite devices, there's another display that I really liked, but I think my favorite device that they had, just because it was so clever, is it was showing kind of how slow build earthquakes happen. Because typically what happens with an earthquake is you have shifting tectonic plate or big body of earth, and it's building pressure from shifting, and then eventually something gives way and it pops, and that's what unleashes all that energy in an earthquake. This was a little device that had 2 boards, and you would connect the boards with toothpicks, this little slots, and then you would crank one of them, and it would move the board toward you, and it would pull the other board, but the other board was on a spring. So eventually, the toothpick would no longer be able to hold the spring back and snap, and the board would shoot forward and knock a ball off, which is such a cool, it's a neat device that I wanted to play with had we had more time and less people who also wanted to do it. But it's also a really cool way to explain how an earthquake works. It's not just the earth shaking. It's not the earth having shivers. I like it. Yeah.
There was a lot of stuff at the museum. A lot of the science center itself had some cool earthquake demos.
It did. Some fun animated ones that were really, really clever.
Yep, we got to push, just like little kids. It's great.
Yes.
To something that's engaged. We got on either side of the transform boundary and slid them past each other.
We shifted the earth.
I think my favorite earthquake thing at any of the tables was the guy who had the liquefaction demonstration.
Absolutely. I was going to mention that one. It was awesome.
He had a little Tupperware container full of sand, actual earthquake sand.
Yeah. We have our own little vials of it.
We got little vials of earthquake sand. This is sand that gets pushed up in the New Madrid zone, where you get some earthquakes. It's sand that gets pushed up through fissures when earthquakes happen.
It's basically like sand geysers, just gets forced out through cracks.
And he had a container full of that with water.
Yep.
And liquefaction is when an earthquake shakes up sediment, and if there's water in it, it loosens the sediment, and you basically get quicksand kind of effects. And he'd mix it up in his container and then start shaking it. And he had placed like a toy car and other, like a toy building, I think.
He had a couple of batteries to represent heavy structures.
Yes. On top of the sand, and as he like slammed it quickly up and down on the table, the things on the top would sink
and like fall over
and get sucked into the liquefying sand. And that was cool. I was like, all right, that's neat. And then he had it must have been a hollow.
It was a Easter egg that had been taped closed so that it was waterproof.
And it was meant to demonstrate like a tank, like a septic tank or something under the water. And I hadn't under the ground, and I hadn't known that it was in the sand. And it started emerging from underground,
surfacing.
It was such a cool, simple, do-it-at-home demonstration.
The reason that it was really catching is that, it makes sense. When things shake, things fall down. And the liquefaction, the fact that the car can get stuck in the mud, because the car didn't fall down, but its wheels sunk down. And it was the fact, your car can almost instantly get stuck in what once was solid, sandy ground, all of a sudden is liquid. But when the capsule starts to emerge is when you realize that density works 2 ways. And it was fascinating. Things you don't think about because most people aren't experiencing vessels from under the ground raising up due to an earthquake.
It was very cool. We also had a long discussion with the guy with the screen who is showing earthquake models, how you model the motion of earthquake waves, which was really cool.
Yeah, he was talking about the fact that you have to teach computers how to model that. So it's such a complex system that you actually have to parse it out for a supercomputer to be able to get all the details in line. Which was, it was really interesting. A side of earthquakes you don't think about is if you want to understand them, you have to model them. If you want to model them, you have to have a computer that's up to the task, because this is covering states.
Or in this case, many, many computers that can work together to be up to the task.
It was a cool table.
There was also there were some rock tables, rocks and minerals. There was one table with a bunch of meteorites.
Yeah,
cut really cool
cross sections of meteorites, and they were awesome.
Yeah, well, they've got all that wonderful iron and similar structuring inside.
I think my favorite thing that he mentioned to us was he pointed to one of the meteorites and was talking about that it was one of these kind that finally got scientists to believe that rocks fell from space.
Yes.
Which was just one of those concepts that you don't think about being a thing that we once didn't believe. But of course we didn't. Saying a rock fell from space sounds like a crazy person's...
Yeah, it's ridiculous.
Yeah, okay, well, you obviously need to be committed because you're seeing things fall from the sky. But nowadays it's so commonplace, we don't think of there being any other option. It's cool to have a little bit of history to that.
And I liked that the year he mentioned that I think it was around the late 1700s or so into the 1800s that they were starting to accept that, which I thought is interesting because that's around a similar time that we were starting to accept that extinction was a real thing.
So they're on similar timelines.
That's just a fun correlation. We didn't link the two of them until the late 1900s.
Took us a little while.
And then the other cool thing that I definitely wanted to mention geology-wise is that 3 of the fireside chat interactive ask people some questions things during the day were paleo related. There was a volcano demonstration put on by Brian, who was also very cool.
He was a lot of fun.
Yes. And there was a talk by
Mr. NASA.
Michael Bouchard, a NASA Earth and Space Science Fellow at Washington University, who talked about geology on Mars.
It was a cool talk.
It was a cool talk. He did a great job. Also, lots of fun questions from the audience. And he showed the coolest video.
Oh my goodness.
The Mars helicopter.
He talked about, he went into a lot of detail about what each of the rovers has been able to do up till now, and like what research they've been able to do and how much we've been able to learn from them, and then talked about that the next one is planned to have a helicopter drone.
Yes.
This is where I remind everyone that I have a minor in astrophysics and I love this stuff. Oh my gosh, it was so cool.
And he was fun to talk to about that stuff.
Yes, he was a lot of fun.
It was cool because we've both interacted with a lot of scientists, and not everyone is great at talking to a general audience.
Yeah.
Sometimes that's hard to do, and sometimes it's something that doesn't come easily to people, especially once you've gotten so far into your field that you're so used to that high level of expertise in academics. This event was a great opportunity to interact with scientists who were good at that.
Yes.
Who were well practiced. And so it was just a whole bunch of really good science communicating working scientists. And speaking of which, why don't we go ahead and play our final 2 interviews with the last duo that did the final paleontology fireside chat. These are Dr. Liz Freedman Fowler of Dickinson State University and Josh Matthews of the Burpee Museum of Natural History. Listen in. Hello, Liz.
Hi.
Please introduce yourself.
I am Dr. Liz Freedman Fowler. I graduated from Montana State University. My PhD advisor was Jack Horner. And now I'm in North Dakota teaching at Dickinson State University.
Excellent. And you are one of the invited paleontologists for SciFest today.
Yeah.
What kind of paleontology do you do?
My research focuses on, in some ways, anything in the late Cretaceous of North America, but specifically I most focus on hadrosaurs, the duck-billed dinosaurs, and looking at how they grow, both ontogenetically and how they evolve over time, and kind of the correlation between the two, the ontogenetic changes and the evolutionary changes.
Oh, interesting. Yeah, I noticed on your table, so you have a table set up like all the rest of the paleontologists today do. You have all these wonderful long bones, limb bones, and then thin section photos.
Yeah, so I couldn't actually bring a microscope slide and a microscope, so I brought poster-sized printouts of what the bones look like in through the microscope. So we tend to cut the long bones, so you want a big sturdy limb bone like a tibia or a femur, and you cut it, make a very thin slice all the way across the midsection, grind it so thin you can see light through it, and then look at it under the microscope. And just like tree rings, dinosaurs have annual growth lines, and you can count up how many years old it is. So that's what I was showing today. I was showing off some posters of the histology, because many people don't realize that's a thing, that you can actually, in many animals, treat them like tree rings and count up how many years old they are.
Yes.
I feel like it probably wasn't that long ago that there would have been, just the idea of saying, can we learn about dinosaur growth? Like that would have been the question. How did dinosaurs grow? But now histology and growth studies have become so diverse. What sort of questions are you specifically looking for?
They're growing more diverse all the time. Histology's really undergone a bit of a revolution. In the past 10, 20 years, dinosaur histology started way back 100 years ago. People started looking at the cross-section of bone and basically saying, isn't that pretty? That's about how far it went. And there was a bit of a resurgence, so people like Jack Horner, some colleagues in France, Jacques Gauthier, and a few other people really revitalized dinosaur paleohistology. And once you start looking at a lot of dinosaur bones, you can start seeing trends and patterns. And so not only how old was it when it died, that's the basic question, but you can look at the rate at which it grew at different points in its life. And so they grow really, really fast when they're young, and then the growth slows down. Some dinosaur species lived longer than other species did. And you can even, looking at the shape of that graph of how the rate they grow changes every year, there's some little inflection points in the graph. And you can see when they reach sexual maturity and probably start reproducing, laying eggs, and then skeletal maturity where they reach their full adult body size and stop growing. And then when you have a really large sample size like we did for Maiasaura, one of the other PhD students with me, Holly Woodward, the main focus of her PhD was taking all the tibiae from the Maiasaura bone bed, so she had a sample size of 50 bones, and cut them all up, counted up all their ages, and so we used that to make a combined growth curve. But then also you can make a mortality curve when you have that. And so we know how old each animal was when it died. And so you can look at kind of the death rates. And so, yeah, of course, they die most when they're young. Most animals are most vulnerable when they're young. They tend to survive pretty well when they're in their peak years. So that actually lines up with the years between reaching sexual maturity and then reaching skeletal maturity. So while they're, a good adult, not fully grown, but still growing a bit, but reproducing, laying eggs, they're in their prime of their life. And they tend to survive pretty well. And then they reach full skeletal size and they go into old age. It goes into senescence and they start dying.
That's very cool.
So you've gone from the
field,
royal you,
the field,
everybody,
yes.
Including you specifically, have gone from isn't that pretty, the inside of this bone, to population dynamics by looking at those growth patterns.
Yeah. And they are still pretty.
Yes,
Yeah.
they
are.
They are still pretty.
Thin sections are like, you've seen those things online where it's like science art, where it's things under microscopes and galaxy pictures and stuff.
A lot of histology just makes great art. We want to blow up some big wall-sized poster printouts of some of it. And at the Museum of the Rockies, the histology technician there, Ellen Lamb, she enters every year into a microscope photography contest.
Oh, nice.
So she's in the calendar every year pretty much with one of the dinosaur slides.
To bring that around to, the sort of topic of the day here at Scientific Outreach, do you ever find that eye-catching quality of thin sections, I imagine that sort of having pretty science to present is helpful when you're doing things like your table today, trying to get this information to the public.
Yeah, it certainly draws the eye, especially we'd like to print it out the size of a whole wall and just really add a lot of color to the museum because they're very colorful. Generally, most dinosaur bone in histo slides comes out various shades of orange because dinosaur bone's typically brown, and you grind it so thin you can see light through it. It's going to look orange. And then depending how you change the filters on the microscope, you can make it a whole hallucinogenic rainbow of colors, which is always fun. But yeah, it's just eye-catching and beautiful, and people have never seen anything like that. People typically have not seen a slide of what bone looks like, and certainly not in that color. A human bone slide, they don't usually stain them, and so it's just gray and white. It's not nearly as beautiful as the dinosaur ones and all their rings of orange.
And how has your SciFest experience been today?
It's been great. I've been really impressed just how well organized everything is. It's run really smoothly. They've got so many staff to set things up and do things for you, and just everyone's been really helpful. So it's gone great.
I agree. It's been really nice.
It's been a fun event. It's been going really well.
Yeah, I think everyone had fun.
Yes.
It's nice when you get to do, you're doing you did a talk, and you're doing your table, and we're doing our various podcast stuff. It's nice to feel like you have all the support you need for that. Like you don't have to, when you have to leave your table, there's somebody to cover that. And
Exactly, yeah. It's been a big team effort.
Yes.
Definitely.
do you do a lot of outreach at events like this?
We do. We don't. The museum in Dickinson is obviously much smaller than the museum in St. Louis, but we do various events out in the community. And anytime there's a community festival in the park and everybody's got tables, the museum's out there with a table, and Denver brings along some of his favorite fossils and other things, talks about whatever interests him that week. But yeah, we've been to a fair few of those events. So.
Excellent. And you are also giving another talk later this evening, right?
Yes, we are also doing talks. We're just doing all sorts of things. We didn't really know what to expect when we signed on for this.
And what is your evening talk going to be about?
My evening talk is going to be kind of a very short summary of my dissertation work on the evolution and growth of hadrosaurs. So, trying to condense an entire 500-page dissertation into a 1-hour talk for my defense was enough, and now I'm condensing it into 20 minutes for the public with a lot of background explanation. So, it's going to be, we're going to cover a lot of territory.
And can you condense that into 60 seconds of a teaser for this interview?
Yeah, so like I said, I look at the evolution and the growth of dinosaurs, and so there's this correlation between their ontogeny, how an individual changes as it grows up, and it is also reflected in the evolutionary trends we see. So my work focused on 2 different species of hadrosaur dinosaurs, Griposaurus and Brachylophosaurus, or the lineage of Brachylophosaurus. And so seeing how these 2 lineages evolved. And so we have juveniles of them, subadults and adults. And so the nasal crest grows, it gets bigger as the animal gets older. It also gets bigger over evolutionary time. And so there's corresponding trends in the ontogeny and the evolution. And so that's called heterochrony, where changes in the timing and growth of a structure is related to the evolution.
Right,
cool.
Right.
Neat.
Very cool. Now I'm excited to hear more about that at your talk later.
Yeah. Ontogeny really does recapitulate phylogeny in a lot of cases.
It does. We talked about that on one of our episodes.
Yes, ontogeny is a fun one.
Yes.
Yeah.
Well, Liz, thank you so much for letting us take some of your time today.
You're very welcome. It's been fun.
Absolutely.
Hello, Josh.
How you doing?
Good. How are you?
I'm wonderful. Great to be here.
Please introduce yourself.
My name is Josh Matthews. I am the Director of Paleontology at the Burpee Museum of Natural History in Rockford, Illinois.
Excellent. And you are one of the invited paleontologists at SciFest today.
I am.
So what sort of paleontology do you do?
I'm predominantly a field paleontologist. At the museum, I have a lot of responsibilities. We're a smaller museum, so we don't, I wish I could say every day I'm in there doing research. However, that's just not the reality behind it. So, but I work in Montana and Utah primarily. So I run field expeditions out there every summer. We do, beginning this summer, we're in Utah working in the Jurassic Morrison Formation. And then later in the summer, we go to the Hell Creek in southeastern Montana. So,
cool.
Yeah.
Excellent. And you have a table here at SciFest today.
I do, yep. We brought a lot of goodies from the collection back to the Burpee. I got Jane's skull. Jane's our juvenile Tyrannosaurus rex that we found in 2001. Kind of the specimen that's the debate still continues whether it's a juvenile Tyrannosaurus rex or the Nanotyrannus.
Yeah.
But, that'll hopefully be settled one day, but it probably never will be settled. So I brought her skull, and I brought some other specimens from Montana and from Utah, just kind of show the kids hands-on, touch a real dinosaur bones. It's cool to touch casts, but they always ask, "Is this real?" And if you say no, you can see the subtle disappointment in their eyes.
I've always found that interesting of the replica versus the real thing, because people have the same thing when it comes to like movie props.
Yep, exactly.
And it's just that they want to know that it is, because with the movie props it's especially funny because they're both fake.
Right.
Like neither one's a real gun.
Yeah.
But one was held by a person. One was in the ground at some point, and they want to know that.
Yeah, exactly.
And that's an interesting thing.
Right. And it's interesting when you're building exhibits.
Mm-hmm.
Do you put that on the exhibit tag? This is a cast, or do you just let them decide for themselves?
Yeah.
Mm-hmm. And I don't know what the right answer is there, but but you still get that. Is it real? Is it real?
Yeah.
Oh yeah. I that's something that always comes up at the museum where I'm at, is that I hate the question of is it real, because it implies that the alternative is that it's fake.
Yeah. Absolutely.
And I always try to stress that point that a replica is not a fake. And what I always like to say is like a statue of George Washington is not a fake George Washington.
Mm-hmm.
We're not trying to trick you.
Yes,
absolutely.
It's a model.
Right.
It's a representation. And trying to get people away from that. Because
they even use that. I have them at the museum. Is this fake?
Mm-hmm.
Oh yeah.
No. It's not fake at all. It's not a creation.
Yes.
It's an exact replica of specimen, detail by detail. Everything is there. So
at the aquarium, the equivalent question of that is we have a place where they can dig for shark's teeth, and a lot of times they'll bring something over and they said, "Is this anything?" Mm-hmm. And my response is, "Well, yes, yes, it is.
Yes,
it is a thing." And so I will usually give them the detailed explanation of what kind of shell it is, which they're never satisfied with. They want it to be a shark tooth, but there's that question: is this anything? Well, yes, it is. It's just not what you care about.
Exactly.
You know?
It's still cool.
Yes, it's still cool. It's fascinating.
Absolutely.
And it's the same issue there. Like, it may not be the one that came out of the ground, but it's just as valid for what we're showing you.
And I'm sure I was that way when I was younger too.
Mm-hmm.
I don't know, but now I don't. Makes no difference to me. I went to have you ever been to Thanksgiving Point in Salt Lake City?
Mm-mm.
They have the Museum of Ancient Life, and almost all of it is cast specimens, but it's so well put together. And it's specimens you don't see in typical museums like Triceratops, T-Rex, stuff like that. So it makes no difference to me anymore. I think it's all cool.
Well, I think that's the big thing for me is that a cast allows you to share.
Right.
Which
absolutely.
is really, really crucial.
Right. That's kind of the point of why we do this.
Yes.
So.
And at your table today, you have a nice combination, it seems, of original fossil and cast material.
Yeah. Yep. And some of that cast is, especially that little alligatoroid we have, the actual skull is disarticulated. So that's not always impressive. It is impressive to someone who want to come in and say, that's a skull. Like, they look at it and go, oh, is that a skull? It's a bunch of little pieces. Well, those pieces go together to form the skull. So bringing the cast really, even though it's not real, they still, a lot of people, I've gotten a lot of good comments on that little guy. So it's something different. So.
And how has your table been?
It's been really well attended. We've had a constant flow of people through there. More of the adults tend to be more interested than the children often, but a lot of the kids just want to touch.
Yeah.
But so that's why some of the specimens they bring, they're strong, they're robust, they can handle a kid touching it. Some of the other things, the more delicate stuff, we keep further back on the table, and they still try to reach, but no, it's been fun. It's been really good.
Very cool.
Is this sort of outreach and interacting with the public, is this something you get to do at the Burpee a lot too?
Actually, quite a bit. Actually, we do a lot of events through the museum, through the education department. Like coming up, we'll have National Fossil Day. For us, we're celebrating that on October 6th because we have a number of events coming up, and we're trying to space them out so we don't get overworked. But so with that event, we have stations set up all across the museum. So we're going to have a station with Jane's real skull, because Jane's real skull isn't actually on exhibit. It's disarticulated. We keep that in the collections for research, basically. So last year we started for the first time. I built a little ethofoam cradle for it, and each bone sits in there really nicely, and that was kind of our marketing. Come see Jane's real skull.
Very cool.
Most people don't get to see it. Now, when people come in, if I'm talking about Jane, I always do tell them that's not the real skull. The real skull is disarticulated in collections. And if we wanted to use the real skull, you'd almost have to break the real bones to get them to look right. And we don't do that, so we mold and cast them, and I tell them the process. But the opportunity to come and see the actual skull, it's exciting for a lot of people.
Yeah.
So we do that. We do just a number of little stations throughout the museum. So that's for National Fossil Day. Come October, we'll have one called Night Sounds. It's more of it's not a paleontology theme one, but we have stations again around. I do mad scientist type stuff, dry ice experiments. Then we have the art of hunting, so we do more of an anthropological one. So we have a lot of events where we get to do this type of thing. And then in March is our biggest. We have Paleo Fest, which is where we bring in paleontologists from across the world to talk for 2 days. To the general public, it's more scientific. Well, it's not more scientific. It's scientific and aimed towards the general public. So the general, and we always tell the speakers this: we're like, don't dumb it down. This group doesn't want to dumb down talk. They want to hear the science. They want to know the science behind what you're doing. But it's not an SVP talk.
Yeah, it needs to be explained.
Yeah, exactly. And it's so that this past year was our 20th Paleo Fest. So that one, our 21st will be coming up next March. So yeah, we get to do quite a bit of outreach, and it's fun. It's great to interact with the public, and again, they're dinosaurs. You can see the excitement in their eyes.
Yeah.
So.
Yeah. It's cool to see that here at SciFest and then you with Paleo Fest are doing these events where it's not just come see some cool stuff.
Yeah.
It's come listen to and meet the actual scientists
learn.
doing the work.
Yes. Yeah.
What do you think is the importance of? Do you think it's better for the public to be interacting with the actual scientists?
Absolutely.
And why?
Absolutely, because I think there's a sense of, well, these people are real. I mean, when I was a kid, Jack Horner, Bob Bacher, those were all, my heroes, quote unquote, growing up. But you kind of got them up on this pedestal that, oh my God, I want to talk to this guy, but I'm scared.
Yeah.
What if he thinks I'm, I ask stupid questions. And once you meet them and you get to talking with them, you realize they're not good. They're just another person. And then you can get the information out of them you want. If you're scared to talk to them, but you want to learn something, you're not going to. So if you get the opportunity to interact with these scientists, these paleontologists, to realize they're just like you and I, you can start actually having a conversation and getting somewhere. So I think it's really important that is done. And that's one of the things with Paleo Fest. I think I'm going to look. I don't know how to do it, what the right answer is, but when we started Paleo Fest back at the Burpee, basically the speaker would talk, and then they just roam around the museum, so anybody could come and talk to him. And we started having like a speaker-ready room, so the talks get out, and the speakers would go sit in a room and talk to themselves, and the public didn't get to interact with them as much.
Yeah.
So I kind of want to figure a way how to tweak that a little bit. So that's why a lot of these people like to come, and they wanted to talk to Phil Curry, they wanted to talk to Jack Horner, they wanted to talk to Paul Sereno and all these other people. So that's why they came. It was special for them. They got to meet these people that they read about all the time. So I haven't figured out how I'm going to do it yet. I mean, it hasn't been bad by any means. It's just changed a little bit than it has in the past. So I think it's very important that they interact with the public, because it's something like this, that's what we're there for. I mean, that's what they want. They want to meet you. They want to talk to this guy, so they can go to their friends and say, "Hey, I just had a conversation with so and so at this place." Nothing more than that, Yeah. So
it helps to remove the mystique.
Yeah, absolutely.
And that separation. That's cool.
Yep.
I had that experience when I was in high school, was when I decided I wanted to be a paleontologist, and I didn't know where to go from there. And my mom said, "Well, why don't you, who's a paleontologist that you've read about or something?" And Paul Sereno was in the news all over at that time.
Totally.
And she said, "Send him an email." And I said, "An email? Like a normal human?"
Exactly.
Reading email? How's he going to read emails from his place in the clouds? That was such a foreign concept to me that I could just contact this person.
Right. Yeah.
And I did, and several months later, after the field season ended, I got a response, and it was really cool.
That was with me. With Jack Horner. Same thing. I emailed him. I emailed him at like 11 o'clock at night one time. I had an email in my inbox at 8 o'clock the next morning.
Wow.
That's cool. You know,
Yeah.
that was, for me, he took the time to read my email and respond. That was something special to me
Yes.
at that time. So, and it's the majority of scientists and paleontologists, I think, are like that. You just gotta do it.
Yes.
Yeah. So what do you think about SciFest this year?
This is great. This is my first time in St. Louis. My first time at St. Louis Science Center, and I'm impressed.
Yeah.
This is a fun museum and a lot going on. So this is something I would definitely come back for in a heartbeat.
Mm-hmm.
Excellent. You got to do the fireside chats.
I did.
They're calling it,
Mm-hmm.
which are sort of less structured, more impromptu.
Sure.
And I haven't seen that sort of structure done at events like this before.
I haven't either, really.
How did you feel about that?
I loved it. I didn't, going into it, I didn't know the questions ahead of time, so I'm like, hey, let's just wing it, and it's just do it. Just if you don't know something, just say, I don't know, but I enjoyed it. It was good fun time. Liz and I, we know each other, so we were able to kind of bounce back and forth with one another. So yeah, it was a good time.
Yeah.
I love seeing the little kids just right up front, have perfect attention, and that's what's been fun. There's a lot of these little kids. We've had one of them who he stayed at our table for a long time, and got lots of dialogue between him and Dan, actually, my assistant down there, and he bring up questions like, I really don't know if this is a kid T-Rex because this is a big skull. Stuff like that.
Yeah.
I love because they're thinking, something's going on, so it's fun to see.
The little problem solvers.
Yeah.
Going, mind cranking the problem through.
Yep, it's fun.
And are you giving a talk later today?
I am.
As part
yes.
of the evening
Yep,
event?
this evening.
And very briefly, what's your talk going to be about?
I'm basically going to talk about the building a paleontology program at a smaller to mid-sized museum. So the Burpee Museum is a small museum, and we didn't really have a paleontology program until around 18 years ago, and kind of the process we undertook to do that and where it's led to today. So kind of going over our different field work in Montana and Utah, how we found the sites, how we kind of decided we're going to do this.
Yeah.
So I think it's cool for this is definitely bigger than the Burpee Museum, but if they want to start a paleontology program, get it going again in terms of funding, getting something funding, I think it'd be neat to explain. This is how we did it.
Yeah.
Right.
Take it for what it is. You don't want it, cool, but it can be done.
Yeah.
We're a small little museum in Rockford, and we've been fortunate to have a lot of cool finds out in Montana, which kind of put us on the map. So that's what it's going to be about, basically.
Excellent. That should be really good.
Mm-hmm.
Josh, thanks so much for talking with us.
No problem. Thank you for having me. I appreciate it.
So there you have it. SciFest 2018, Rock Fossil Quake in St. Louis. A really fun event.
A lot of fun. It was a joy to be there.
It was, and it was a preliminary test for them in a lot of ways. And I think it went really well.
Yes.
Will and I were talking a little bit earlier about what we would... Hopefully this happens again.
Yes. This was their first run of this event. So this was their maiden voyage, so to speak.
Yes. And we hope that it happens again. Whether or not we get to be there, we think that this was a really good opportunity for outreach.
Mm-hmm.
And we were talking a bit earlier amongst ourselves about what we would hope to see in the future. We think there's a lot of potential here.
Yes, absolutely.
So in the interest of some feedback, I think personally that one of the things that this event did really well was, as I've mentioned earlier in this discussion, giving people the opportunity to interact with the professional scientists. And I was surprised at how well it did that.
Yes.
And I think that, honestly, I think that they could have gotten away with doing even more sort of panel discussion time and just Q&A with audience time, because the audience, young and old, was really into that.
Yeah, they were eating up the chance to ask questions and even engage in conversation in the panel setting, in the fireside chat settings. I absolutely think that, especially if they do this around and we're able to get more people coming in once they know it from last year, that they can lean into that, because it went really well.
Yeah, I'd love to see. I think that the panel discussion at the end of the day was a lot of fun. I would love to see that go on even longer.
Yes.
I think that was really cool.
Absolutely. Yeah, the event went extremely well, and my one of my big hopes, like I mentioned, would be that if they were to do it again, now it hopefully will be better known within the community, and they can actually get audiences to fill the seats and allow them to do more talks, or bigger talks, or longer talks, or all that kind of stuff. All of them went well this time, but I'd love to see this event grow, and so I'm hoping they do it again.
It was funny, I think we were talking to Liz, Dr. Freedman Fowler, at one point about the flow of visitors.
Mm-hmm.
And she commented that it was a steady, consistent stream of guests, but not overwhelming.
Yes.
And I think that it's, obviously too many visitors is a good problem to have. And I think if this event grows, I think that there were so many awesome people at the tables and engaging guests that I would hope it would be easy to add more, to invite more people. And it seemed to work out really well to bring in paleontologists from around the country. They might be able, hopefully to get away with doing that for other professions.
Yes.
Bring in other people from seismologists and stuff.
Absolutely. Yeah, to really explore all three of the concepts in rock, fossil, and Quake.
Yes.
Because the tables for all three subjects were really cool. We were focusing on the paleo side, but it'd be cool to see people from the other two also getting to come in and show off.
Absolutely. And I think that they did a great job choosing who to invite.
Yeah.
And I think that that's a little bit of an overshadowed consideration sometimes, where I think sometimes it can be easy to say, oh, well, we'll just invite professionals. And you kind of get that college class scenario where you have, this topic, go teach it to people.
Yes.
And not all college professors are great teachers.
Yeah, exactly.
And I think they did a very good job making sure your panels and your tables and everything had people, professional scientists or members of various organizations of varying ages, who did a very good job explaining and communicating the science.
Yes.
I think it was really cool to see this level of engagement on all sides.
Absolutely. No, I completely agree. It went very smoothly and went very well. I think the biggest thing that they can do if they do this again to guarantee it goes well is to invite us again.
I think so.
Yes.
I think that was really the key ingredient.
Well, we will be your lucky rabbit's foot.
There you go. We'll ensure that everything. Honestly, it's funny. We joke. We were there to document, to interview, to see how everything went. We would love to participate more than that.
Oh yeah.
In events like this, but without us, this event would have been fantastic. This was. We cannot take credit for any, even the tiniest of things that made this event go well. Dr. Morhardt and the crew at the university and the Science Center did a really good job, and it was an honor to be able to be there and participate.
We were literally flies on the wall for this one, and we were glad to be so, because it was a lot of fun, and the guests seemed to have a blast. They were just very engaged, very energetic. That's the thing I noticed all day, is the energy was very up and consistent. And, it never felt like there was a moment where everything just died down.
No.
It was a very warm and excited atmosphere.
Yes. So, huge thanks to Ashley, to Dr. Morhardt, to Ruth, and to all the paleontologists, and to Brian, and to everybody who participated and
absolutely
who helped us, who interviewed with us, and who helped us get around and get acquainted with the area and everything. We had a great time. Also, shout out to our friend Dr. Leah Lynch, who housed us.
Yes.
Thanks, Leah.
Thank you.
That was great. Shout out to Summer. It was a really cool event, and I hope that the people there will use this as a jumping off point to do more events like this. And I hope that people who hear about the event will be encouraged to think about their own science communication and outreach and ways that they can interact with the community. I think that there is a lot of value, and this is the last time I'll say this, I think there is a lot of value to finding creative and interesting ways to get the public directly engaged with the science, with how we do the science, and with the scientists themselves.
Absolutely. No, this was a very picturesque example of scientist outreach to the public.
And thank you, listeners, for listening. We'll put up a blog post with a bunch of pictures and stuff from the event so you can see some of the stuff we've been talking about. It has been our pleasure to bring you some notes from the world of paleontology science outreach.
From the field.
From the field of people who are back from the field. This was a lot of fun. We hope you have had fun listening to it. If so, let us know. As always, if you heard something, you liked it, let us know and we'll do more of it.
Definitely.
Until then, goodbye for now.
Ta-ta, everybody.
Go out and learn. And science.
Go to the science center and then you can go to the zoo afterward. It's a cool place.
This is a cool place.
Thanks for listening to the Common Descent Podcast. You can follow us on Facebook, Twitter, YouTube, and check our WordPress blog for pictures and links after each episode. Huge thanks to our patrons whose support helps keep this podcast running and who get access to bonus goodies on Patreon. The song you're hearing is called On the Origin of Species by Protodome, which we found at ocremix.org. Thanks again for listening. We hope you'll join us next time.